So, okay, so yes, it will be so useful. With us today is here is the Dr. Eric Rotner. He is with us. I mean, from the University of Germany. From 2008 to 2011, he did his PhD in computer vision and transfer learning. From 2012 to 13, he did his postdoc in Berkeley University. And later he moved from 2014 to 2016. He was like lecturer and in the group leader in the University of Jena. From 2017 to 18, he was a senior scientist in SAIS corporate research. And from 2018 to 2020, he was like a head of machine learning in SAIS corporate research. And finally, from 2020 to nowadays, he's professor in machine learning and data scientist, and also in Berlin. So, I mean, he have a huge background. And thank you once more to stay with us. So, we are hearing your talk that he named Advances in Machine Learning, Challenges and Opportunities Ahead. So, thank you so much.
Yeah, thanks a lot for this nice introduction. And first, I have to confess, I'm not able to speak Spanish. So therefore, it's always tricky for me to track all the organization. But thanks a lot for the nice English introduction. Also, one important remark to my CV is I added this here to the slide that I had really awesome stays in Mexico as well during my time as a PhD and also as a postdoc. We had several collaborations, so I visited Humberto Sosa for quite some time and was a great time. So it's really an honor for me to give this talk here. One important remark towards the talk. So the talk is not meant that I simply speak 1 hour and you listen. You can ask, you are very much invited to ask questions for the chat. So just look at the chat and try to answer also your questions in between if you have one. And I would very much appreciate that. If you ask a question, just please in English. Otherwise, it would be hard for me to grasp the idea of your question as well. And I think that would be great. Yeah? Okay, then, so basically, I named my talk, as you can see, I have a background in machine learning, and I named my talk Advances in Machine Learning. So, I mean, as you know, there has been some development in the last years that got not unnoticed. I have to say. So, and maybe let's make a first quick round, and everybody can say simply, yes, I fear the further development of AI, or I fear that I miss opportunities in AI that AI might offer. So are you more on the side that fears the development of AI, or are you just welcoming opportunities? So please just remark that in the chat. I think that will be great. So everybody was using the chat already, so I think it would be great as a starter to also mention that. If you wanted to, can also do that later on. So basically, there are always two sides on the story, and let's consider that a bit. So first of all, I mean, as you know, there has been such a rapid progress in AI in all of these years. And most importantly, it's, I think, very much important that everybody realize that deep learning, machine learning, I mean, it's not a hype, right? That it simply happens currently. It's something that has its roots already in the 70s and the 80s, and especially some of the algorithms that we use in computer vision nowadays, they have their roots in 1989. So basically, there was a time when basically Jan LeCun invented convolutional neural networks, and these were basically the algorithms that showed really huge progress and success also in the computer vision research and application world. So we have seen these very important milestones in computer vision. 2012 that allowed us now to have a lot of applications. And also to in the natural language processing world, 2017, when transformer layers were invented by a bunch of people at Google. And basically this leads to all of the work that we've seen nowadays with GPT models, ChatGPT now being pretty omnipresent in quite a lot of application. And we have later on large language models as autonomous agents that play a huge role. So not only simply answering your questions, but also solving certain tasks for you. Yeah, we have video generation with the Sora model. I mean, if you haven't seen all of these YouTube videos on video generation, please look at them. I think that gives you a certain glimpse of what will happen in the next 2 years. And all of the further releases that we've seen so far. Yeah. And I think the question we should be asking ourselves, and which might our grandkids will ask us, so where have we been when AI was taking off, and what was our contribution? Not only for me as a professor, but also for you as students and young researchers. What have you done? What was your impact on this side of the story, and where have you been, and how have you experienced this important time to be in, with all of the challenges and difficulties ahead? So I'm from computer vision. So basically, looking at all of these applications that I simply gathered for you is, you could say that visual recognition it's solved, right? I mean, you can detect quite a lot of objects and natural images with just a few lines of Python code. So there's a huge opportunity also for people now that might not have the interest or the experience and all of the mathematical details machine learning usually deals with, but are able to do proper software development. And basically you have the tools now that without really deep knowledge in neural networks, you can do a lot of exciting things. So I've just gathered examples from Facebook, basically certain data set they released. We have seen other works that deal with segmentation, so really detecting certain things in images. We have examples like object detection, as I mentioned. We have seen these applications in microscopy and medicine having a huge impact. And a lot of these things, you could say, especially for natural images, it looks like it's solved. But for certain applications in industry, but also in the health sector, microscopy, it's not really solved because you always require a lot of annotated data, which is hard to get. And that's something to keep in mind here. But it's also to keep in mind that this is progress of the last decades, of the last two decades. So basically, when I started doing computer vision, we were happy that we could differentiate cats and dogs in images, and everything else was impossible. And this dramatically changed. Okay, so basically, the question is, artificial intelligence is quite a big term, but actually you could say it's just math. And where this question holds, let's answer this in my presentation. I also will show you why the first machine learning engineer lived basically centuries ago. So let's see about that. And also we will talk about the challenges and opportunities in AI that we are confronted with. And I also will talk a bit about AI research in Berlin, in the University of Applied Sciences, that which is my location to basically lecture, which is my main job, but also do research. Okay, there are certain areas of AI that people talk about. And of course, it's one big topic that's omnipresent in the last years, which is generative AI. everything related to generating text, generating answers with respect to questions, generating images. Yeah, you can see these were a very early version of stable diffusion, one of the main algorithms that drives the area of generating images and videos. And it does not look any good at all, but things changed dramatically in the last 2 years, such that you can't recognize anything else. But there are also other areas of machine learning. So I rather use the term machine learning, which is basically prediction. So what we also do at our university is applications like predictive maintenance, that you try to predict when a machine is failing. You try to predict with sensor knowledge when a machine is failing, and when an error might occur. So that's basically an area which is called prediction. And that's something that people have done for centuries already, right? I mean, even the early mathematicians. Then we have the area of recognition, recognizing things in images, recognizing things in speech. Also, you could say that speech recognition is solved. And also translation tasks. Translation tasks rather are related to generative AI nowadays. And we have the classical field of machine learning, which are recommendation models. So every time when you shop things and when you listen to music on Amazon Music or what kind of other provider you use, you get things recommended, and they are based on machine learning and especially matrix factorizations. So how does it actually work? I guess you've heard quite a lot of talks on machine learning already that try to explain what's going on. But let me look into that also together with you in this talk a bit. Yeah. So I will basically show you my classical 10 slides that explain machine learning and especially supervised learning in a few things. Okay, first of all, question to the audience: can you recognize what this image shows? Maybe you can answer in the chat. I'm not sure the chat is available for answers currently. Maybe not. No idea. Okay. Thanks, Ivan Gonzalez for answering. No idea? Nobody? A cable, yeah, perfect. Thanks a lot for a cross section of a cable. Exactly. So it's not a coconut, yeah, which it looks like, for me, it always looks like a coconut with things in it, but it's exactly a cross section of a cable. And the goal is to say, okay, is this cross section showing a cable which is correct, or is it showing a cable which is defective? Yeah. So basically, you need an algorithm that says, oh, okay, it's okay. Yeah. There's no failure in it, and it's okay, or it's defective. Yeah. So basically, that's the goal. So okay or defective. So basically, this is the image X. Yeah. So now you see we can use math to formulate all of these things. Yeah. So basically, you can say, okay, this is the input that we're giving to the algorithm, and then we have as an output the output. Let's call it Y. Yeah. That's output Y and then input X. And basically, I think I have an echo. If there's a question, just go ahead. But okay. And basically, there's this one slide that shows basically the summary of machine learning. Yeah. You're very much welcome to answer questions, but or to ask questions. So basically, there's always this one slide that I show to explain machine learning and especially supervised machine learning. So basically, we have images and we want to detect whether they are defective or not. Or we have certain other data, and we would, for example, an image of a person, and we would like to estimate the age of the person. So all the things they boil down to finding a model. Yeah, like you like you know from school, right? You have a function that takes as an input an x and returns an output y. Nothing more, nothing less, right? That's it. And the easiest model that we can think of mathematically is simply a line in the space, yeah, which can be modeled with two parameters. Yeah, so basically you have the slope and the offset, and these parameters, they determine the machine learning model. So, and you see, I already changed my wording from line to machine learning model. So basically, the only thing that you need to know about machine learning is basically this one single slide, because basically what we are doing the whole time, especially in supervised machine learning, is that you try to find the parameters of a model that fits to your data. So your data are basically pairs of inputs X and outputs Y. Yeah, so we need, for supervised machine learning, you need like cable cross sections, and you need an expert or a group of experts that judge on all of these images and say, okay, that's a defect, and that's okay. Yeah? Nothing more, nothing less. Yeah, or with the face regression example that I was giving, a lot of images, and then you basically try to predict the age of the people, and you need a data set that shows people, and you have the certain ground truth. It's called ground truth, the age. Yeah? And then basically it's all about trying to find a model, an algorithm that given an X returns a Y. You know? And usually you do that in software development. You try to find a model yourself with all your experience, but in machine learning, you try to learn the model from data. And that's the only difference. So basically machine learning is all about finding models that fit to your data. Yeah? Or for a large part of machine learning that we are confronted with currently. Let's put it this way. Yeah? And basically, if I don't know if this reminds you, there was a, of course, I'm mentioning a German mathematician here now. So basically, Carl Friedrich Gauss was one of the greatest minds in the math world, and he did work on linear regression. Basically, it was the first one to write down linear regression, the linear regression problem, and finding a solution, which is called the least squares estimation problem. So basically, you could say that he was the first machine learning engineer. Okay, so let's talk a bit about generative AI and how generative AI actually works. So, and I think although none of us has as native language English, I think we can all basically end the sentence properly. Yeah, to be or not to be, that is a question, right? It's a typical Shakespeare sentence. This one is more difficult. Life is like riding a bicycle. To keep your balance, you must keep. Maybe write it in your chat. What do you think should be here? Give it a try. It's a sentence from Albert Einstein. You must keep moving. Exactly. Yeah, thanks a lot. The ability to speak does not make you. That's a more difficult one for all Star Wars fans. That's Star Wars Episode 1. It's a citation of Qui-Gon Jinn. Its ability to speak does not make you intelligent, which is a quite important sentence, especially when you talk about large language models and their intelligence. Yeah, thanks a lot for mentioning that in the chat. So basically what large language models, they learn from text. Yeah? They learn from gaps in text. So basically you're confronted with, sorry, I still have the German phrase here. So it's basically finding the gaps or the blanks in sentences, yeah, the missing words. Yeah? And we've seen in 2012, when it's about computer vision, the best models that you can learn, very generic, very foundational models, can be learned by trying to solve a challenging image classification task. So in 2012 and before that, people from Stanford and Google collected a large data set of Flickr images. Yeah. Flickr, large photo portal, and to quite a lot of people, they uploaded photos without any license. So, and thanks to all of them who uploaded their cat photos, they basically went into a large data set that people use to develop computer vision algorithms and also to learn large models. So basically that accelerated the progress quite a lot. And for natural language processing is all about finding missing words. So you have quite a lot of text on the internet, and you can use this text and try to find and blank out certain words, and then the algorithm needs to find the words. So how does it work? Let's take this important sentence about my own university. So this sentence is HDW offers over 70 study programs in the area of areas of technology, computing, and so on and so on. And you see that first of all, we separate the text in really words, basically. It's most of the time words. It's called tokens. For some words you can see they are split into 2 tokens, but basically, especially for the English language, they are a token is basically a word. Yeah? For special words that are not in vocabulary, you need more tokens to represent one word. So let's split that in all of these things, and let's take this part of the text, which is called engineering and business administration. Let's blank out one word, and let's provide this sentence to the learning algorithm, and the learning algorithm needs to figure out what's missing. So what's in the blank spot? Okay, so one solution is, of course, that would be a classical Google solution is, let's search in a gigantic database for a matching phrase. So you could search for engineering and business and then look into certain texts that, how do they continue? Yeah, there might be multiple choices, but there's certainly one which is most probable. So that would be the first solution. Solution number 2, because I mean, I guess you can see the disadvantages of solution 1 already. If you think about ChatGPT, always trying to search in the gigantic database parts of your prompt that you provide, that does not scale at all, right? I mean, we would not have a talk with these systems the way we would have. It would be enormous computational effort, and then you only get the things that are already in the data set. Right? So there's no interpolation and things like that. But solution number 2 is that we basically represent a word by numbers, yeah, which is basically by a vector. So a word or a token, to be correctly, is a vector. Yeah? A set of numbers. And then we use mathematical operations to calculate the vector of the next word. So we try to find a mathematical formula to calculate the next word. Yeah? Sounds strange, but it is the way it is. Yeah? Okay, so basically try to find that. And I made a video which simplifies a lot of things, but I think it helps to understand the process here. So first of all, sorry for that. So first of all, every word, every token is represented as one vector. So that's the input that you provide to the algorithm. And that's basically the AI model. So it's a German video. So these are the parameters of the model. Yeah, so we have imagine that it's a model that we are using before. It's a line which has 2 parameters. So basically, it's all about trying to tweak these 2 parameters of the model and finding the certain operation. Okay, so and then let's try to find the correct. Sorry. So represent every word as a vector. And then let's try to compute the vector of the next word. So then basically it's all about trying to tweak the model, to change the parameters such that you get the correct vector. And in the beginning of the learning, it might be the completely wrong vector for a wrong word. It does not match with the data that you have. And then you try to tweak the model such that the vector that the model returns fits to your data set. And that's it, basically trying to find the correct parameters of a model. That's basically the gist of machine learning in this sense. So it's not about finding anything in the database, it's trying to find a formula that provides you with the next word. And a formula that also matches with nearly everything that you can plug into the model, nearly every text. Because we are not doing that with just one sentence and trying to find the parameters for this just one sentence. We are trying to find the parameters that work for all possible sentences that are in the database in our learning set. And then it might find, after certain numerical optimization, the right vector. Okay, and of course, the models do not have just 2 parameters, they have 175 billion parameters. And of course, as an input, we don't have just 400 or just one sentence. We basically have 500 billion tokens that go into the optimization process. Yeah? So of course, my video only shows a small aspect of it, but I think the concept is very similar to what you see in other learning procedures for GPT models. Yeah? Of course, it's not 2 parameters. It's GPT-4, nearly 2 trillion parameters, and I don't know how many tokens go into this training process. Maybe, I don't know, 10% of the internet or something like that. Okay, and if you compare, basically my brain has 86 billion neurons, or that's an estimate I found in publications. And this model has 1.76 trillion parameters. I think I'm not sure we can win in the long run. Let me phrase this way. Okay, so basically this is a pre-training phase. Basically, once you have these really large models, you can do a lot of interesting things with it. Yeah, you can basically tune them to your task that you would like to. Yeah. So basically, for ChatGPT, it was this pre-training phase, and then there was a supervised learning. Later on, there was done with a curated data set. That resulted in the algorithm being able to rate certain. Okay, so and basically then there's a self-learning phase that's going on. So there are I just showed the first step, which is the learning of the foundation model, which is called pre-training phase. But there are a lot of other things involved. So let's listen to a small video snippet. Let's try that, and you say where you can listen to the video. Okay, that does not work. So basically, I have a nice video you can also look at in the internet, but it does not work without any proper sound system. So it's basically a talk between Jensen Huang, which is basically the CEO of NVIDIA, and because of all the machine learning IPs, one of the richest guys in the world, and Ilya Sutskever, which is one of the authors of a 2012 paper that got introduced basically deep learning to the computer vision world in a certain sense, yeah, and which was at the time of the video still working for OpenAI, and they were discussing, and basically Ilya Sutskever explained that these models, although they are just predicting the next word or the next token, from his understanding, they are learning a compressed version of the world knowledge. You know, they are learning a so-called world model They're learning how to maybe not understand text, but how texts in general are generated. Yeah? From a certain world knowledge, and they are trying to compress all of these texts in just a few trillion parameters. So there's basically a debate happening in my field, whereas this is really the case. Yeah, some people say large language models, they have nothing to do with intelligence. Yeah, they are just so-called stochastic parrots. They are just trying to predict the next word. There are other people, including the Nobel Prize laureate, which was announced I think it just yesterday. Jeff Hinton, and basically these guys are saying, okay, large language models are developing towards a certain artificial intelligence, artificial general intelligence, and there's a certain discussion going on. Yeah, and I'm not sure on which side you are. I'm still in the middle and switching back and forth. There are certain arguments that hold true, where basically all of these systems pass quite a lot of intelligence tests that we thought would test for intelligence. So in this sense, they are intelligent. But still they are based on just training data and not physical experience. But you have to decide on which side you are. Okay. So basically, what are the consequences and opportunities? So one consequence that if you understand the principle of large language models is that, of course, there is no factual proof in the outputs of the models. It's just computed, right? There's nothing that is proven. It can be completely wrong. Yeah? It's just based on probabilities. But maybe our brain is also based on probabilities, and our answers are also quite often wrong. I know that because I'm teaching students. And also, if the outputs of the models, they can look reasonable, but they don't need to make sense at all. Yeah? Most importantly, model outputs always reflect the data bias. So if you learn from the internet, you learn also from quite a lot of very difficult text, which are provocative, which are have a lot to do with discrimination. There's a racial bias, of course. There's a bias towards Western civilizations, and a lot of things that you don't want to have in the data, but they are in the data, and the model learns from that. So basically, it just shows you a mirror of all the things that are happening in the internet. Algorithms are well known and have been developed worldwide. You can simply train yourself one of these gigantic models from scratch is simply not possible, just for maybe 1-2 companies in the world. But that's it, yeah, or a handful of companies, let's say it this way. It's not possible for anybody else, let's put it this way. And I don't see a good path solving this issue. But you can, of course, if you have access to these foundational models, you can train for your task. Okay, but there are so many opportunities ahead. You can do complex data transformations with AI models. You can use AI as a trainer. We've seen faster software development times, but also quite more challenges in teaching. For example, we built at our university a coding mentor that people can use to basically get additional assistance. And it works in English and German and was implemented in 5 minutes. And that works great. Of course, what does not work great is when people simply use ChatGPT right from the start, because then you are not able to verify the solutions that these systems give. Yeah? And if you are not able to verify these solutions, you should not use them. If you are able to verify the solutions yourself and also test it properly and understand these solutions, then you should use these tools, of course, yeah, because it accelerates your work. So that's what we basically do. Especially in our courses, they basically have a first year where they are not allowed to use these tools. because they need to understand and only use then these tools as coding mentors, but later on, of course, they can use that. Okay. So of course, challenge on one, everything is changing. Yeah? Jobs are changing. There are interesting estimates that also quite a lot of jobs, they will not maybe disappear, but also the people that work in these jobs will reduce. For example, if you think about a designer, you can now generate all your marketing material with the tools that you have. And if you are a designer and you can accelerate your work, it simply means that less designers are necessary to do the job. They are also changing the business model landscape. If you do not have access to foundation models as a company, you definitely have a problem. Yeah? So I'm happy about the open source development currently, but if you don't have access, you can't reach the quality that you need in some applications. Luckily, we have open source models. This is just a state for May 2023, which is in my world like centuries ago. Yeah, and a lot has happened also with Llama 3 now from Facebook research and fix that up. Okay, challenge number 3. Of course, you can generate everything yourself. So basically, everything can be fake. You can't trust any image, you can't trust a video or audio or anything. Yeah? That's simply the fact. And development is basically there's an explosion of development. It's hard to keep up, but we need to deal with that currently. That's definitely a challenge. Another challenge is data bias. I mentioned that already. So some of the data that ChatGPT has been using for training, they are from sites, pages like Russia Today or 4chan, sites that you might not want to use when it comes to fact-proven stories. And there's also a problem because minority data gets simply neglected when there's a topic that is not part of the large world of the internet. That's a huge problem. Okay, cost is a problem as well, and also computation. Okay, let's move to one exciting some research aspects. And I think it's not your lunchtime already, so I think you can survive this video. I'm not sure you know what kind of video is it. You have to guess. And if you are not able to look at this video, that's okay. Just close your eyes. Okay. And you have to guess what you see. So what kind of surgery is it? Does anyone has an idea? It looks like an eye, exactly. Yeah, it's an eye, but what kind of surgery? A surgery that at least 10 people in the audience will have when they are 70. It's the most common surgery in the world. See that? Okay, so it's basically a cataract surgery. So if you have in German it's called grauer Star. Yeah? So basically your lens gets blurred after a certain time and it needs to be replaced. Yeah? So I was working for a company that works in this area, and what we did is basically providing an algorithm that analyzes these surgery videos. Yeah? And basically, this surgery is basically divided in certain phases, so you can detect them just visually. And that's what we are working on. We are working on also medical computer vision and trying to improve basically the pipeline people use. So currently, it's quite a lot of hassle to annotate data. And because usually you have to annotate quite a lot of images, which takes quite a lot of time. And then there's a model learning phase, and evaluation is happening. And basically, takes quite a lot of time to invest that, and we are working on also improving data annotation, speeding that up, and also improving the learning phase that you can learn from our data, basically. Okay, so it's all about the data. Let me come to one thing in the end. So basically, there's a project I'm working on which deals with how can we speed up applying foundation models, because as I said, learning foundation models is nearly impossible to do ourselves, but bringing them to a certain application is possible. And the question is, how can we speed up the last mile of annotation? How can we adapt foundation models in this sense? And that's something that I work on also in my lab. Yeah. Another thing that we worked on, I mentioned that in the beginning, is predictive maintenance. So basically, we have a certain lab where people and especially students work on, and they can place certain sensors in the system and also simulate errors happening in the machine. And then we try to, with other algorithms, try to detect these errors or trying to predict these errors happening in the future. So that's quite an interesting area to be in. Another area that we work on is anomaly detection. So basically, you have videos, and just basically a time series of images, or you can consider text as a series of words, or weather anomalies. And what we did is we basically developed an algorithm that can detect these certain anomalies in time series to a large, which can be used for a large set of applications. Okay, and basically the algorithm is really based on very simple mathematical aspects, and can be implemented also quite efficiently. So this is just a motivation that it's really important to learn the mathematical basics and to understand them, because then you can apply them to machine learning properly. Okay. Let me come to the end. So basically, one important thing to mention here is that do not consider large language models and machine learning models in general as some intelligent black box. It's really the basic of these principles are really simple mathematics and can be learned quite easily. And if you understand these basic principles, you can also derive a lot of aspects that you need to consider when working with them, for example. There are plenty of challenges and opportunities ahead, and definitely don't miss this amazing time and contribute to it. So thanks a lot. So that would be the end of my talk. And if you have any further questions, I'm happy to answer them.
Well, I will speak in Spanish. Okay, so, well, si tienen algunas preguntas, pueden hacerlas en el chat o preguntarle directamente. Entonces, pues esperamos sus preguntas. They gave you one question in the answer in the chat. Do you have some? Do you have access?
Yeah, I see the chat. So okay, let me answer this question first from Alejandro. So programs that he repeats the question. Programs that recognize a song like Shazam are considered AI. So you can consider it because they need to learn from data in a certain sense. I mean, I'm always trying to avoid what should be considered AI and what's not AI, because that can be really an endless debate without any impact on anything. But for me, it's basically machine learning is a science of models that are learned from data, and in this sense, Shazam should be considered as a sort of machine learning, or used to learn machine learning. The main limitations and challenges of visual recognition, Santiago was asking. Exactly. So basically, what a lot of computer vision models can now be applied to natural images quite easily, and it's easy to detect people and cars and things that exist in the natural world around us. because we have a lot of images and annotated images from public everyday life images available in datasets. We can learn from them quite easily. So these tasks are quite easy nowadays to solve. However, what's not easy to solve is tasks that are related to problems in industry, because images in industry, they look different. You can't find related material on the internet easily. And of course, it's easier to develop these algorithms, but still there's quite a lot of challenges when collecting and annotating this data. And the same holds for medical applications as well. Yeah, but you could say if you have properly curated data, then nearly everything can be solved in computer vision nowadays. That might be a provocative statement. I'm not sure my colleague Rojas will agree, but we'll see about it.
Professor, I have another question that this is from my side. I hear about the debate about, like LLMs are stochastic parrots or they are able to develop some intelligence. And I know, like you said to the public, you have to take a side. So which is your side? What do you think about that?
Yeah, that's true. And I think I said you have to decide for a certain side to be on. But I can't really decide. Yeah, I'm switching back and forth, I have to say. Yeah? I mean, we have seen it's hard because I think in the last two years we changed our measurements for intelligence. Yeah, before that there was a Turing test, so that you confront people with a chatbot, and if people are able to recognize whether this is a human or not. When people are not able to recognize this chatbot as being synthetic or artificial and think that's a human being, then it should be considered as intelligent. But I think if you do experience, and also there have been experience around, a lot of these chatbots, they pass the Turing test depending on the people that you're confronted with. And it's the same holds for certain tests for universities and things like that. So I think there's a certain level of intelligence that goes beyond the simple stochastics. Yeah, although it's based on stochastic models. Yeah? So I think we can't neglect that at all. Although these models are based on simple math, but maybe we ourselves are based on simple math and biology working together in physics. I don't know.
It makes sense. Yeah. I agree with that. So, ¿tienen más preguntas o estamos bien?
Yeah, there was a.
I think we can finish this this talk with the last question you have in the chat. Would it be safe to use image recognition for finding maybe tumors or some kind of cancer in the human body?
Would it be safe? I guess it depends on the people that developed it, right? And I think it's your task in the future to develop it such that it is really safe. Yeah? And I think a lot of measures have to be taken there. But just consider this, right? And you have to decide in 2-3 years when you go to a doctor, you have to decide whether you trust your local doctor or whether you trust a system that has learned and has the experience of thousands and 10,000s and millions of doctors. And then it's a question whether you trust one doctor or the experience and the knowledge of several doctors. But of course, it depends on the development, and I think we have to be very transparent when it comes to the development of these systems and to very carefully test and evaluate them.
Okay. Well, thank you so much for this insightful talk. Thank you, because I think that also you gave, we learned lots of things, and something that I really like from this talk is that you didn't only talk about the natural language processing or vision, but of both of them. And I think this is so nice from your side. So thank you so much, Doctor, and we hope to see you soon in another event.
Yeah, that will be great. Okay, thanks a lot. Thanks for inviting me again.
Okay. Thank you so much.